A toy car with a rocket engine moves along a horizontal track as shown in the figure. The rocket engine produces a constant forward force of 4.6 Newton. The car loses mass continuously as exhaust gases are produced by the rocket. Use momentum consideration to explain why the rocket produces a forward force on the car. The gases and fuel are initially at rest with respect to the car. The gases and the car are an isolated system, hence according to the principle of conservation of linear momentum, the total momentum of the system must remain constant at all times. As the engine expels the exhaust gas backwards, there is an increase in momentum of these gases in the backward direction. Therefore, there should be an equal increase in the momentum of the rest of the car in the forward direction in order for the total momentum of the system to be conserved. By Newton's second law, there is a net driving force on the car that is proportional to the rate of change of momentum of the car. The variation with time of the speed of the car is shown in the figure. At time t equal to 2 seconds, the mass of the car is 440 grams. Use the figure to determine the acceleration of the car at 2 seconds. So the gradient of the tangent to the velocity time graphs at time 2 seconds represent the acceleration at that time. So using the coordinates here at 4 and 13.6 as well as 0 and 2.8, we get acceleration of 2.7 meter per second squared. Use your answer to determine the magnitude of the resistive force acting on the car. Now, given that the driving force is 4.6 Newton, let the resistive force be F. So by Newton's second law, the resultant force equal to ma. So the resultant force will be F minus friction. So we get the friction as 3.4 Newton. Explain how it can be deduced that the resistive forces acting on the car increase with increase of speed. So from the graph, we note that the acceleration given by the gradient of the velocity time graph decreases with increase of speed. Hence, the net force also decreases with increase of speed. So the net force is the driving force minus resistive force. Therefore, the resistive force must increase with increase of speed since the driving force is constant. The toy car is now refueled and then rotated so that it is pointing upwards. It is suggested that the rocket engine produces sufficient force to propel the car vertically. By considering the acceleration of the car at time equal to 0, comment on this suggestion. So the acceleration at time equal to 0 is given by this gradient tangent to the VT graph at time 0. So we get acceleration at 6.4 meter per second square. So let the weight of the car at time equals 0 be W. So W equal to mg and m will be equal to F over A. So that means that the weight will be 7.1 Newton. So it's not possible to propel the car upwards because the thrust of the engine is 4.6 Newton and the weight is 7.1 Newton. So that means the thrust is less than the weight. So it's not possible to propel it upwards.